Hi everyone! Let's talk about average atomic mass and mass spectroscopy. In this video, we'll talk about what isotopes are, how to calculate average atomic mass, and how to read a mass spectrum. The mass of atoms comes from its protons plus its neutrons. Now, the special thing about protons is that the atoms of the same element will always have the same number of protons. We call this the atomic number. So for the same element, protons is always the same, but that's not the case with neutrons. The number of neutrons can change. This brings us to isotopes, which are atoms of the same element with different numbers of neutrons and therefore different masses. You can see isotopes written in a couple of different ways. This first notation is called isotope notation. It has the element symbol. The number on the top is the mass, which is protons plus neutrons, and the number on the bottom is the atomic number, or the number of protons. Since the number of protons doesn't change, you might also see simplified notations that only show the mass and not the number of protons. We call this isotope carbon-12, which is carbon with a mass of 12, and another isotope of carbon is carbon-14, which has a mass of 14. Isotopes have something called relative abundance, which is the percentage of an isotope in a naturally occurring sample of an element. For example, chlorine has two isotopes, chlorine-35 and chlorine-37. Chlorine-35 has a relative abundance of 76%, and chlorine-37 has a relative abundance of 24%. In nature, there's more chlorine-35 than chlorine-37, which is why the mass of chlorine on the periodic table is closer to 35. All masses on the periodic table are averages of the element's isotopes, which is why they're all decimal numbers. Let's go into how to calculate this average atomic mass. Here's the equation. Average atomic mass is the sum of the decimal abundance times the isotope mass. This looks like a complicated equation, but let me show you how easy it is to use. Here's an example. Lithium has two isotopes. Lithium-6 has a relative abundance of 7.59%, and lithium-7 has a relative abundance of 92.41%. What is the average atomic mass of lithium? To solve for average atomic mass, we need the decimal abundance, which is just the percentages converted into decimals. You can do that by dividing the percent by 100. So 7.59% turns into 0.0759. Then we multiply this decimal abundance by the isotope mass, which is 6. This is one isotope, and I'll add the next isotope. For lithium-7, I have 92.41%, which is 0.9241 times 7. The average atomic mass of lithium is 6.92 AMU. Now let's get into mass spectrums. Sometimes you won't get the isotope masses and relative abundance written out in a sentence. Instead, you'll be given a graph showing the isotope masses and their relative abundance, like this, and this is a mass spectrum. It's important to know that each bar is an isotope. When I look at this mass spectrum, I see that there are two bars, so there are two isotopes. This first isotope has a mass of 35 and a relative abundance of 76%. This second isotope has a mass of 37 and a relative abundance of 24%. Once you have this information, you can use the same equation as before to solve for average atomic mass. Convert the percentages to decimals, multiply by the isotope mass, and add the isotopes together. You can apply the skills you're learning in this video to identify unknown elements. First, you have to be given a mass spectrum, or the relative abundance of different isotopes. Then you find the average atomic mass. Finally, match that mass with the periodic table and you'll know which element you have. Let's look at an example. What is the identity of the element shown in the mass spectrum? First of all, my first look at the spectrum tells me that this element has 4 isotopes because there are 4 bars. The most abundant isotope has a mass of 56 because that's my highest bar. I can already start to guess what element this is because I can go to the periodic table and see which element has a mass closest to 56. That would be iron. I can also take the information from this mass spectrum and solve the average atomic mass equation. Here, I've listed out the masses and their relative abundance. I'll take these numbers and plug them into the equation. The percentages have been turned into decimals, and I multiplied them by the isotope masses and added all the isotopes together. The average atomic mass is 55.91 AMU. On the periodic table, iron has a mass of 55.85, which is super close, so my unknown element is iron. I hope the concepts in this video were easy and painless. Thank you for watching and happy studying!